Today I'll be talking about how you can make your React apps intelligent by using cloud AI technologies. More specifically, we'll be looking at how we can solve an enterprise search problem, its challenges, reference architecture, and its implementation. To introduce myself, my name is SahanSeraDEV. I have been working as a software engineer for almost a decade now. You can follow me on Twitter with the handle _SahanSera, and I usually blog at SahanSeraDEV. Okay, so this is the agenda for my talk. We will start talking about the search problem, the key building blocks, and things like that. By the way, before we start, I just want to tell you that you can download the demo by scanning this QR code on the slide. If not, you can follow this link here, which says github.com/SahanSeraRGS2022 demo. And I have also put this link at the footer of each slide. You will find the fully working source code that we are going to have a look at today. Now to the interesting parts. Let's have a look at the typical React app. Let's imagine we have a web app which is built with React. This could be an existing app or something you are going to be building from scratch. It could be a public-facing app or even an internal one. More specifically, let's say we are creating a blogging platform where users can publish posts. So at the top here, we have a button and a bunch of cards to show some of the data that we have. There can be some data fetching going on, maybe under the hood, state management and some event listeners to respond to users' actions, and maybe some configuration. Okay, let's go a little bit further and understand some of the behaviors that we have in this app. So as we said earlier, there can be some initial data fetching that's going on, and when you click on the post button, you can publish a new blog post, and that goes to a new page where you have this form saying title and the content, so you can write something in there and click on submit, and you can publish your blog post like that. And finally, you have this view button on each of these cards where you can click on that and view more details for each of these items that we have. So it's pretty straightforward and simple so far. Now imagine your customers or some of the key stakeholders want your team to make this content searchable. What kind of challenges do we have to solve? So there could be some problems that we might have to face if we are to build this. So maybe you have to ingest data from many sources and consolidate them together and then make them searchable. Do you think that your traditional database search is going to work like a full text search? It might, up to a certain extent. But if you want to enrich your data automatically, can you do that? Or can you deliver that while providing a great user experience to the user? In modern days, these concerns can be boiled down to 4 key building blocks. So first, you need to have some kind of a data source. It can be an existing database or maybe a collection of databases, or it could be even a blob storage with some documents. Then we need to extract important bits from this data and make that data searchable. You are going to need some kind of a search index. This is also known as an inverted index. So far so good, and now we have to create a pipeline to automate this process. That's why we need an indexer. So that would poll your data and extract out the important parts out of it and put that into the search index. And then finally, we can even go beyond our usual search index by enriching the dataset by using some of the AI technologies to understand the intent, or maybe to identify some key phrases and etc. You might be thinking, cool, I get that, but I know all the components, but how can we put them together? Can you be a little bit more specific, Sahan? In a usual implementation, this is what the data flow is going to look like. So starting from the React app, we can push data to a data store and let the rest handle the searching. The indexer will fetch the data from the data source and run through an AI enricher to augment the dataset. Sometimes you would have the indexer embedded inside the search index itself as a separate process, but you get the idea. And then finally, we have the search index hydrated with the final output. Then we can use the React app to query that data and give the results back to the user. Should we build all these components ourselves? Just like with everything else, it depends. But usually the answer is no. There are many great technologies out there to solve these kind of search problems. This short list of search technologies I have used in the past and using currently. Major cloud providers have their own versions. All of these have pros and cons, obviously. For demonstration purposes, however, I'll be using Azure Cognitive Search since it has all the tooling that we need under one roof. Okay, so let's go more deeper and flesh out our initial system design with more granularity. So this is the architecture of what we are going to be building today. So starting from the left, we have the users accessing our web app through a web browser, and our web app is going to be consisting of a React frontend with components such as pages, Axios calls, static assets, and state management and stuff like that. So I have left out some of the details in here. And we are going to be building a backend as well, which will host our API endpoints. So these endpoints would talk to the database as well as our query engine. And the technology choices are going to be React for the front end and Next.js to serve our web app and to create the backend API. So the reason for creating a backend is to encapsulate some of the cross-cutting concerns such as configuration, security, logging, etc. So here we have the cognitive search instance along with the AI enrichment. So we will go into much more detail when we are going to be building this. So don't worry right now, we will see all of these in action in a little bit. So let's talk about what kind of changes do we actually need on the front end as well. So let's look at that now. Okay, so remember how we had a header in our web app, and we are going to be introducing a new component which is going to be like a search input, and the design of the card is not going to change. It's going to be the same thing, and however we now have some additional fields in our data model. So these are going to be like automatically hydrated when we create the search index and when we have the indexer process going on, and it's going to be awesome, trust me, to see this in action. Alright, so I hope now you have a basic understanding of what we are going to be building today, and let's get right into it. Okay, so here we have VS Code open up onto your left hand side, and to your right hand side we have the browser opened up, and at the top we have the terminal to run some commands. So let me open up the architecture diagram and show you which section we are talking about. So here we have the client side and the backend API configuration, and then we are going to be building this in React and Next.js. So if I'm to build something like this, I would normally go to the create React app, but for the time being I'm going to be using something called Maintain UI. So it actually comes up with a lot of UI components, even hooks and theming capabilities. And then of course Next.js is going to be kind of like the server-side rendering or the backend to host our web app. So once we have that setup going on, let's go to VS Code and open up the project structure. So it is very similar to a Next.js application. So here we have the components, models, pages, and then the public assets. So if you go to the pages section over here, you can see the API as well as rest of the stuff. So the rest is going to be like the React application. So in Next.js, you would have something called _app, which is going to act like the root, the container for the application. So if I open that up, okay, so if I scroll down a little bit, so here we have the return function where we say like, this is the header. So app shell is going to be where you have all your, the components are going to be rendered, or the pages are going to be rendered. So for example, if I go back to Maintain's documentation, and under Maintain core, under layout, you would see app shell. So it has some, basic theming and styles over here, so you can just copy and paste and change it accordingly. Let's try to run this first and see this in action. Okay, so yeah, that's all booted up. And if I go to React Global Summit application and then refresh that, yeah, it's loading up. So here we have our application which we saw earlier in the presentation, and these are the cards that we have. So let's go ahead and search for something like Google. Yep, so that will load it up, and then we can see the Google document, and then about Go language. So yeah, that's how this application works, and we will go much more deeper when we go through each and every section. So after that, here we have some links over here. Yeah, that is to show this link, and then another link to represent like post new blog post. So that's pretty much it in terms of the folder structure for the React app. And for the backend service, here we have like this index.ts, and that is to handle all the database connectivity, and then this Azure Cognitive Services connectivity. So let's go back to our index.tsx, which actually represents the home page. So if I go in there, as you can see, there's nothing in there. So that is this page over here. And if I just save it, yeah, nothing appears. So we import the use router, that is to extract out the query parameters in the URL. So whenever we search for something, we can grab that query parameter and then apply a search on top of it. And then here we have use state hook, that is to do state management for the cards. And here we have like this initial data fetching. So whenever we load up this page, it is going to fetch data for us. So whenever we do a query, or whether we are opening up the page for the first time, it would make an Axios call to our API endpoint called API/post, and then with this query parameter. So and then once you get the response back, it will set the cards onto the page. And we have a use effect to invoke that function. Scroll down a little bit. So here in the return function, we are showing the cards, and then in this simple grid we have these components getting rendered up called result card functionality of the search bar. So I'll just go over here, click on that, and type something in, search for something. Yep. So let me go inside the search input component. So as you can see, it's a pretty basic component, and I have this input box, and then this is a component that's coming in from Mantine UI. And on key down, I'm calling this function. So here we are saying like, unless it is an enter, just return out of the function. If not, we are actually getting the value from here, and then calling this on search function, which we saw earlier in the underscore app tsx. If I go in here and then click on this one, and then as you can see, we have the title and the content. And I'll show you how this one works. So I have a Wikipedia page open up over here. So I'll just go in here and then copy something in. Go back to here, and then just say TypeScript. Paste that in. Submit it. So it says posting. Yep. So that got posted successfully. So at the moment you wouldn't see that result over here, but I'll get to that later. So we need to have some kind of a database to hold all this information, right? So that's where the backend API comes into handy. So for example, if I go into API/post and click on the index.ts, this is where we have all the endpoints that we are going to be creating today. And if I scroll down a little bit further, as you can see, everything that hits this endpoint is going to go through this function, that is like the handler. So we have the access to the request and the response, and then we are checking, is this like a post or is it like a get, and then depending on that we call different methods. So I haven't implemented that yet, so I'll put them back again. So this is the function to create a new post, which we saw earlier. So we get the request, and then we access the body of that, and then we set it to the title or the content, and then we generate like a new ID for that, and then we create this data model, and then we send that into to the table client, which is like a database that we have in Azure. So I'll show you how we can provision something like that, and then once that's done, we just return the ID of the newly created post. And then in terms of getting all the posts, have this function over here. So this is where we are calling the Azure Cognitive Search Service, and then one of its endpoints to say what is the search URL and the index, the name of the index, and then what is the search parameter. So that's pretty much it. And then when we call that, we pass in the search key. So this is something that's important to understand. So if we are to do something like this purely on the browser side of things, we will be exposing this key to the users, right? So that's also like another reason to improve the security of these calls that I opted in to have a backend for this. And then once we get the response from the Azure Cognitive Search Service, we just return the the value that we get. So we will have a close look at that when we go into Azure and then provision these services. Let's go to Azure first, and then create the database service, and then after that we will create our Azure Cognitive Service search service resource as well. So I'll go to Azure over here. So the URL is going to be portal.azure.com/home. So you can just type in portal.azure.com, and then once you are there, if you're not familiar with Azure, don't worry about it. You can even use a different search service, as I mentioned earlier, but this is just for the demonstration. So let's go ahead and create like a new database service. So if I go to resource groups, I already have created something called AI search. So resource group is kind of like a container to hold all your resources. So I'll go inside that first, and then I have already created one, but I'll just go ahead and create a new one. Yeah, so the first result, that is the storage account. So I'll click on create and select the resource group that you want to add it into, and then the storage account name. So this has to be unique. I'll say RGS 2022 index storage or something like that. I hope that's available, and then you can pick whichever the region that you want that to be in. So other than that, if I go ahead, you can keep everything as defaults, and then go to networking, defaults everywhere. If you don't need that, you can just untick them. So that's what I did just for the demonstrations. And then encryption, and then once that's done, it will go to the review and create page, and then once the validation passes, you can go ahead and create that. So once everything is created, I'll go back to my resource group. So you will get something like this. Yep. And then once that's all loaded up, what we really need is this tables function. So we will go into that. I think I already created one. Yes. So that's this table over here that's called posts. So this is going to be the the tables endpoint. So this is https AI search storage.table.core.windows.com.net, and then slash whatever the name of the table. So you can even go ahead and create a new one, something like ABC, and then click OK. So it will create the table for you, and then once that's done, yeah, so this is going to be like the tables endpoint slash ABC. So since I already have a posts table, let's see what we have in there. So let's go into the storage browser, click on tables. So here we have the posts, and so these are some of the blog posts that I had created initially. So the partition key, you can even partition by giving your own custom key, and then there's a unique row key that you have to add there when you are creating. So these columns, you can have as many columns as you want. This is like a NoSQL database, and then I have this ID, so I'm going to actually copy the same ID as the row key over here. So if I scroll down a little bit more, yeah, so partition key, that's the post, and then the row key and the ID key, as you can see, we have the same thing, and then the title and the content. So if you remember in our previous section, we created a new post called TypeScript. So that's what we are seeing over here. So if I click on edit, I should be able to see all the properties and then the values as well. So that's pretty much it. And then something that you actually should note here is like we have these default properties, right? But after that we only have like these three properties like ID, title, and content. So these are the actual, the data that we sent out to the database. So if I close that and then let's go back to the web app, let's click on React and then click on view, let it load, and then the title, the content, and as you can see there are some different attributes. And if I zoom this in a little bit more, different attributes like organizations, locations, people, key phrases, and stuff like that. But we don't have any of those in this tables columns. So how are we getting that? So that's where the Azure Cognitive Search Service comes into handy. Okay, so now that we have seen how to create the database, let's move on to our resource group and create another resource that is called AI Search Index, which is going to be essentially our Azure Cognitive Search Index. So let's click on create, and then we will type in cognitive search. Yep, that's exactly what we need, and click on create. So resource group, and then you have to give it a name, and then so these are the constraints for that. So I'll just call it something like RGS 2022 search index, and then the location or the region that you want that to be in. So some of the regions are not available for this one, but most of them are. And then the pricing tier. So there are many different pricing tiers over here. For the time being, I'm going to select free and select next. Cool. And then we have to select like what kind of scale. So for the free tier, you don't get any kind of scaling. But for example, if you're running like a production system and things like that, then you can select like what kind of replicas that you want. Like for example, it is going to distribute that across regions and things like that. And it would have like read and write replicas, and also you can, as your data set grows, you can even partition that. Like you can say like how many partitions that you want it to create. So you don't get that with the free option, but with every other paid versions you get that. So depending on your situation, you can select whichever the pricing tier that you want. And then once everything is done, you can just go ahead and select create. So what I'm going to do next is to import that data that we created in our previous step. So let's click on that. So I already have one here, but what you can do is like you can select your existing data source. So if you don't already have one, these are the options that you get. So let's say since we have a Azure table storage, I'm going to click on that, and then you can give it a name, anything you want. So posts storage, and then connection string. So if you already have one created, it will automatically pop it up, so you don't have to go and find the connection string. So click on that, then it will hydrate that for you. And manage identity, you don't have to worry about that. And then the table name. So our table was called posts, so you don't have to worry about the query. And then what we can do is now we can set up this pipeline. So if I click on next, let's give it some time to validate. So it has already identified the schema of our database. So now what we can do is we can tell Azure Cognitive Services to utilize our dataset and have different AI models to run on it and extract data out of it. So in here I'm using the free tier, but you can go ahead and create a new one if you want. But since I'm using the free tier, I'm gonna keep it as it is. And then this is the most important bit where we discuss about like how we can add enrichments to your data. So if you can remember, in our database we only had the ID, title, and the contents. So this is where we are going to be adding like more information into this data set. So you can call this any name that you want, and then you can select a granularity level over here. So here you have several options. Extract people's names, organization names, location names, key phrases. So in our case, I'm going to select people's names, organization names, location names, and key phrases. So once you have done that, you can even create visualizations out of this, but we don't need that for this presentation. So let's click on create index. So once that's done, this is the step where we are going to be creating our search index. So in here, as you can see, now it has added all these fields, right? So you can see ID, title, content, and then all the other stuff that's coming in from the pipeline. So here we can say like what's the primary key of this dataset. So you can see even say key or ID. I'm going to pick that up as ID, and then you don't have to worry about any of these, the search modes and things like that. And once that's done, so one other important thing is like when you are searching for your dataset, you have to tell it like, is this attribute is going to be retrievable or not. In some cases, we don't need all of them to be retrievable. So such as partition key, row key, e tag, and all those metadata, we don't need all those popping up in our data model. So everything else we can have them as searchable as well. And then content, yes, I need that to be in the data model. So likewise, you can cherry pick whatever the columns that you want from your dataset. And then once that's done, you can go next and create the search index. Yeah, so in here you get the opportunity to select like a schedule. In my case, since I'm doing this demonstration, I'm going to show you how the indexer is going to work. So I have set it to once so that I can go there and manually do that. And then you can even set it like a hourly thing or daily one, or even like a custom. So I'm going to change this name. You can even set like a custom interval and start time and like that. And yeah, it also has like automatic change tracking. So that's available. So you can say like track deletions and things like that. So soft delete column, delete marker value, and all that kind of advanced options. And yeah, so that's pretty much covers the setup that we have to do in terms of setting up this pipeline. So once you do that, you will get these different items in different tabs. So one thing that you need to note is if you go into the indexes, you will see your index popping up over here, and then the indexer that we created. So if you click on that, you will see like how many executions that we have, the settings and indexer definitions. Let me close that. And then also the data source. So you can have like as many data sources as you want. It doesn't have to be like a table storage. It can be a Cosmos DB thing, blob storage, file storage, and things like that. So yeah, that's pretty awesome. And in the next one, we will see how this works. Okay, so let me open up our web app, but we don't see the TypeScript post that we created, right? So that's because we still haven't run the indexer. So let me go back, and I'll go back to the indexer, click on the indexer, and then now from here we can run it manually. So let me, yeah, okay, and let's run it. So it says, are you sure? Yep, should be all good. And so that has run now. And let me go back and do another refresh. Yes, so at the bottom, you can see the TypeScript post that we created right now. So what about the extra additional fields that it generated, right? We don't see them over here, but let's click on view. And yes, so it has identified the organization just from this particular text, and it doesn't have any locations, but that's fine. No people, key phrases. So key phrases, it has identified like different key phrases in this text. So let me go back to the app, and let's click on something like maybe Amazon. And yeah, for different kind of text, you will find like, it would identify different organizations and locations, people, key phrases. That's pretty cool, right? Because we didn't have to do anything other than like setting up this pipeline, and now it automatically hydrates this information into our data model. That is pretty cool. So you now open up a whole bunch of other use cases for your data set. Okay, let's next talk about configuration. So how do we hook this up to our API layer? So going back to our code, so I have opened up index.ts, which is the API index page. So if I scroll up a little bit, as you can see, I'm hydrating these search URLs, the keys and the endpoints for the database from the environment variables. So I am using a library called Azure Data Tables. So that is to communicate with the Azure Tables storage, and then so from there we get like this client, and then we can utilize that client to talk to the database and push data into it. But it doesn't have to be just adding SDK or something like that, but you can even make like REST calls to these resources. So that's what I have demonstrated. If I scroll down a little bit further, where we talk to the search index, and you can just get the URL to the search index like this, and then pass in the header. So I'm just making like a Axios get call. So if I scroll up a little bit and talk about how do I get these values. So for the search URL, if I go back to Azure, so for the URL you can grab that from here, and for the search keys, you need to go to the keys section, and then from here you can have like a query key. So by using this key you can only make queries, but you can't push data into it. And for the database side of things, I'll go back to our resource group, and I'll go to the storage account. Okay, so click on tables. So the endpoint is going to be from this HTTP part until Windows.NET part, and the database name is going to be /posts, and the account name and key, you can get those values from the access keys section, just like how we saw that in the Azure cognitive search section as well. So from here you can grab the name for the storage account, and then you can get one of these keys, and if one of the keys gets compromised, you can then rotate the key as well. So in the folder structure you will see this .env .local, and then I have hidden the values over here, but then you can have like search URL, search key, DB endpoint, and likewise, and then you can access those values from the environment variables from the Node.js process. So that's pretty much covers the configuration side of things. Okay, so let's quickly recap what we did so far. So we created a React frontend along with a React backend, and then we pushed some data into data storage, and then we created a pipeline to ingest that data, and finally we added some AI enrichment to the data. So now our React app is acting intelligent. So next, let's talk about some of the considerations that you might have to make depending on your technology stack. So there can be certain cases where you have some additional data stores, but that's not supported by Azure. So how can you interface with that? So in such cases, you have to go with some kind of a serverless approach, or maybe you need to have some kind of a middleman where you push the data into that, and then from there, you can push the information into your search index. So since I mentioned serverless again, I'll talk to you about that as well. So if you already don't have a backend for your front-end application, you can still have these kind of features. But again, in terms of having this functionality, it would be beneficial to have some kind of a serverless approach like Azure Functions or AWS Lambda, or some kind of a backend as a service layer. And in terms of scalability, it all depends on the pricing tier that you are going to choose. So different pricing tiers have different scalability options, and as well as for the reliability side of things. So if you have like production workloads that's serving customers that's scattered across the globe, then you might have to work out what's gonna suit you best. And also again, all these fancy features or fancy solutions, they come with a price. So you have to weigh out different options with different cloud vendors, and you have to make a call on that. So let's talk about how we can further improve this. In this demonstration, we only looked at textual information, but of course you can have support for unstructured data such as images, PDFs, and things like that. And also we lightly touched upon this, but you can have translations as well. So rather than just catering one single language, you can have a multilingual application as well, but that all handled by AI. And you can even come up with your own custom AI enrichers as well. So if there's nothing that's going to suit you, you can even combine multiple set of AI enrichers, and you can build on your own. And finally, there's also a really neat feature that is to do like post recommendations. So how Netflix does their recommendations when you open up Netflix. So likewise, you can do a very similar thing as well. The service is called Personalizer. Unfortunately, we didn't have time to go through that, but it would be an awesome addition to this application as well. So that actually wraps up my presentation. I hope you enjoyed it, and I'm more than happy to answer any questions that you may have. Thank you.